Now, if we can differentiate exponential functions that have bases other than e, it makes sense that we should be able to integrate them as well. We've already seen that if we differentiate a to the power of x, we get the natural log of a multiplied by a to the x, and this result's reasonably simple. This one's not bad to actually just remember. But if we forget it, we have learned how to work our way through the steps and find it again. So it makes sense that if we want to integrate this, we will get back to that. But we don't always get these perfect questions, do we? Sometimes a question will look a lot simpler, but it's actually harder to do, because what we want to integrate is the complicated thing to get back to the simple thing. Integrating the simple thing is actually a little bit more complicated. So the first thing to do is to rewrite it as a question you would rather do. It's easier for us to integrate this one because we know what it becomes. It becomes a to the power of x. So we've adjusted our question though, haven't we? That's not what we were given. We've gone and multiplied it by the natural log of a. So to make up for it, we need to divide by the natural log of a. Now these are the same question, except we know how to do this one. It's got a constant out the front, so we can just keep that there. And when we integrate this, we get that. So we just need to make sure that we're multiplying by our constant, and we have it like this, plus c. Now, can you see that if we're multiplying this fraction by a to the power of x, it would look much tidier if we actually just put the a to the power of x on top. Okay, so now we've got ourselves a little bit of a rule. Do we need to memorize this one? Well, again, if you memorize that integrating this gives you this, that's sweet. It's going to be easy to use. It's not on our formula sheet, and we can derive it by working through the steps if we need to. So up to you. If you're good at memorizing formulas, go for it. And the one that I write down, I'd write it like this in your book now, equals a to the power of x over natural log of a plus c. Now, it's not on your formula sheet, but the formula sheet does contain 3 formulas that you can use. Now, let me explain. In advanced maths, we don't need to be able to differentiate logs that have some complicated function in them if the base is not e. If the base is e, yes, we need to know how to do these, all of them. But if the base is not e, we're going to get nice simple questions where that function of x is just going to be x. That's all we're going to get. Similarly, something other than e won't be raised to some nasty power that's full of a complicated function. It'll just be raised to x. And if we're integrating, we'll just be given a to the power of x, or perhaps with some constant out the front. But we won't have a nasty looking function of x. Now these 3 are on our formula sheet, but we're not going to see questions that require us to use them because we won't be given these kinds of questions. But can you use these formulas at a pinch for a simpler question? Of course you can. A function of x, well, that can be as simple as you like. X is a function of x. So if you're worried about memorizing formulas or working your way through these quite complicated procedures, become familiar with your reference sheet now and have a look at the way that they're written and have it beside you while you're doing these questions, because you'll have it in the HSC, and that way you're working with what you have. Now, something to note, if your f of x is just x, then every time these formulas use f dash x, you'll just be needing to put in 1.